So now let's take a look at a few problems. I'm going to start every one of these problems by drawing a line down the middle of the equal sign to remind you that this is one side of your equation and this is the other side, and that you need to keep those two sides balanced. You can think of it as if we were riding on a teeter-totter here, with the c minus 12 on one side and the 7 on the other. So if we think back to our two rules, which again were isolate and balance, we want to isolate c. We want to get c by itself. And in order to do that, we have this minus 12 that's in our way, or a plus a negative 12. You can think of it either way. So we're going to do the opposite of minus 12, which would be plus 12, because if we take c minus 12 plus 12, the 12s will cancel out and leave us with just c. So we've managed to complete rule 1. We've isolated our variable. The second rule to keep in mind, though, is that you also have to keep things in balance. So thinking of that addition property of equality, if I add 12 to the left side, I also have to add 12 to the right side. And when I add 12 to 7, I get c equals 19. Then you want to check your answer and make sure that that works. The way that we do that is to take this 19 and substitute it back into our original equation where we used to have a c. So we're going to have 19 minus 12 on the left side and 7 on the right side. And since 19 minus 12 is 7, our solution checks out. Let's try another one. In this one, we have n plus 6 1/10 equals 1 4/10. So again, I'm going to start with subtracting 6.1 from the left in order to get those to cancel out and leave my variable alone. But if I subtract 6.1 on this side, I need to subtract 6.1 on that side as well. So think back to the rules that you learned about addition and subtraction with signed numbers. Since this one's positive and this one's negative, I'm going to find the difference between them. And I end up with a difference of 4 7/10. Then 6.1 has a larger absolute value than 1.4 does. We're going to keep its sign, and we end up with a final answer of n equals negative 4.7. Then we go back to check that. Is negative 4.7 plus 6.1 really equal to 1.4? So again, I do the left side of my equation, subtracting a 4.7 from 6.1 and getting 1.4. So in fact, these sides are equal, so I chose the correct answer. N is equal to a negative 4.7. In this next example, we see that the variable is on the right-hand side. So in order to get it alone, we're going to have to subtract 4 from both sides. Negative 8, take away an additional 4, would leave us at negative 12, equaling z. And you'll notice I usually write my z's with a line through them. That helps me keep them straight between the 2 and the z, not confusing those. Then to check this answer, negative 8 should equal negative 12 plus 4. And sure enough, negative 12 plus 4 is negative 8. So my answer works out. These are all examples of the addition and subtraction properties of equality. The next examples that we're going to look at are going to talk about the multiplication and division properties of equality. So once again, my goal is to isolate my variable. I want v to be on the left side of the equation all by itself. Right now it's getting multiplied by a 2. So if I divide it by 2, the 2's will go away, leaving me with v alone. But if I divide the left side by 2, the property of equality says I have to do the same thing to the right side. So 8.6 divided by 2 will leave me with 4.3. And since the 8.6 is negative and the 2 is not, the Valentine rules tell me that v is equal to a negative 4.3. To check this, I'm going to put negative 4.3 back in my equation in place of the letter v, and check to see if it actually does equal a negative 8.6. Well, since 2 times 3 is 6, and 2 times 4 is 8, and a negative times a positive is a negative, my answer checks. Now this problem looks deceivingly simple. We want t to be alone, and it looks like t is already alone, but that negative sign needs to be removed. So what you want to do is think of it as if there is a negative 1 in front of the t, that's being multiplied by that t. So if I divide by a negative 1, those negatives will cancel out. Negative divided by a negative leaves me with a positive, and will get me t truly alone, even losing its negative sign. But if I divide one side by negative 1, I have to do the same thing to the other, so t is actually equal to negative 4. To check that, I put in the negative 4 in place of the t. So remember, this negative sign that's on the outside is not part of the variable. It's still going to be there. And then this negative sign is part of the variable, so it's going to go here. That minus a negative 4 is supposed to equal positive 4. And sure enough, negative minus negative 4 is equal to 4. Our last example of this type looks at getting rid of a divided 4. In order to get d alone, I have to get rid of a divided 4. And the way to get rid of a divided 4 is to multiply by 4, which is really multiplying by 4/1. As you can see, the 4's will cancel out, leaving us with just a d. But if I multiply by 4 on the left, I also need to multiply by 4 on the right, giving me an answer of negative 36. When I go to check this, I put negative 36 in place of the 4 to see if it will equal negative 9. And since 36 divided by 4 is 9, and a negative divided by a positive is a negative, my answer checks.